Hi, welcome back to physics. We are in week 9. Today we are going to learn how to solve for gravity at any location. So if you are up in the space station circling around the Earth, gravity is different. If you are on Mars, if you are on the moon, you will have different gravity. So we're going to learn the equation that will solve for the gravity anywhere that you're located. Before we do that, we are going to do a quick review. So if you would open up the week 9 folder in Schoology, and if you would click the first link, the circular motion and gravitation review, there's a couple of quick questions for you to go through. If you pause it, get that submitted now. It is unlimited, so if you mess anything up, you can always go back and do it. The other thing that we're going to do before we get started is we're going to make sure we have all of our numbers that we're going to use a lot stored in our calculator. They have tons of exponents. You don't want to have to type them in every single time. So we're going to actually store them in, and here's how we're going to store them. The gravitation constant, you should have stored this last week. If you did not, you're going to do it now. You're going to store it as alpha g because that's how it's written in all of the equations. Okay, the mass of the Earth, 5.98 times 10 to the 24th. We're gonna store that as the letter m for mass of the Earth. And then the radius of the Earth, 6.37 times 10 to the 6th. We're gonna store that as the letter r. So if you want that, you'll hit alpha r. Here is how you type it in. So you're gonna actually type in whichever number you're storing first. You're then gonna hit the button store on the bottom left. Alpha. You're going to pick whichever letter that you want it to be, and then you'll hit enter. The next time you want that number, you just hit alpha m. If you want mass of the Earth, it will dump it in for you. I do have, this won't look exactly like your calculator, but it'll do. So let's say we want to store the mass of the Earth. So I'm going to down here type in 5.98 times 10 caret to the 24th power, and then I'm going to hit enter. So 5.98 times 10 to the 24th, hit enter. Okay, from here, I'm going to hit store, and then I'm going to hit alpha, and then mine is going to bring up the letters of the alphabet. Yours will just already have them on there, and it'll be in whatever color your alpha button was. So store alpha. For me, it brings up the alphabet. Yours will already be written on your calculator. I'm going to pick M for that, and then I'm going to hit enter. And now, anytime that I want the mass of the Earth, I am just going to hit alpha, M, and here it is. And then if you hit enter, you'll see it will put in 5.98 times 10 to the 24th. All right, you're going to do that for each of those 3 numbers. Pause here if you need to. Get the 6.67 times 10 to the negative 11 in for G, the mass of the Earth, and then the radius of the Earth. The other thing that we're going to do real quick is we are going to pull up our equation sheets, and in this unit we're going to cross off the equations that we're not going to use. So we can't get to everything this year. We are not going to use the pendulum equation, so I'm going to just cross that off, and you can do the same on your equation sheet. And the other thing that we're not going to look at is when we have cell phone satellites and DirecTV satellites and all of those things floating around, we can actually calculate the velocity of them if we know the gravity that they have at that location. It's just kind of too much to work through, so we're going to cut out that equation as well. We already have learned circular motion equations a week ago. We learned also how things attract each other, that gravitational force, F of G. We've learned and used that equation. We know how to calculate weight. I'm just going to cross off this F of G. Just think of it as weight equals mass times gravity. It's also called gravitational force. That's what that F was for, but you can cross it off. And then right now, we're going to look at how do you solve for gravity at any location. All right, here we go. So we have stored those into our calculators. So now instead of having to type them in each time, we're going to be able to just hit alpha and plug them in. Okay, to solve for gravity at any location, here is our new equation. Little g that has never changed. That always represents the gravity that you feel. On the surface of the Earth, it was our negative 9.8. We are going to find at different places, your gravity is going to be different because the distance and the mass will change depending on where you're located. Capital G, that is still the 6.67 times 10 to the negative 11. You can type that in every time, but we now have it stored as alpha G, so you should not have to type it in all the time. M, that is the mass of the object that is going to be making the gravity. That will be huge objects like the Earth, the Sun, a planet other than the Earth. Alright, it will never be you. You do not make enough, you don't have enough mass to make gravity. You cannot get things to orbit around you, you're not big enough. Only things like a sun, a star, a planet are the only things that can make enough gravity in order to feel it. So this mass, whatever mass you use for each problem, it'll be big. And then finally, R, still think of it as the radius. It's the distance to the center of the object making the gravity. So it measures to the center of the planet, not the surface. It has to go all the way. So if you think of the Earth right here, if we have something orbiting out here, the radius the radius of the orbit does not just get us to the surface, it has to go all the way to the center. Okay, so that's what the R will stand for. All right, the best thing to do is just to try a problem and see if you can get it to work. Example number 1, find the gravity, that's little g, if you are 210,000 meters above the Earth's surface. So there's a satellite floating out there, we're going to try and figure out what the gravity is for that object. All right, so here's our equation. We are going to use gravity, little g, is equal to our gravitation constant, 6.67 times 10 to the negative 11. We need to know the mass of the object creating the gravity. That's the Earth. It's what's keeping the satellite or you in orbit. That mass is 5.98 times 10 to the 24th. It's on the bottom right side of your equation sheet, but we've already stored it into our calculators as m. And then we need the radius. Once again, we are not located. It gave us 210,000 meters above the surface of the Earth. We don't want above the surface, we want to the center of the Earth. So the tricky thing about this is you just have to remember to add that 210,000 to the Earth's radius. Okay, Earth's radius, we have it stored in our calculator. It is 6.37 times 10 to the 6th. It's also on the bottom left side of your equation sheet. To that number, we're going to add, so the Earth's radius gets us from the center to the surface, that's the radius of the Earth, and to that number, to get us to where the satellite is, we're going to add the 210,000 meters above. When I add those two together, I get 6580000. All right, that is, my calculator gives it back to me as a normal number, not scientific notation, so I'm just going to write that down. If yours gave it to you in scientific notation, that's totally fine. Okay, I am now ready to actually plug in the things that I know. All right, so I am solving for gravity. It is equal to capital G. I'm going to write it both ways so that you guys can see. Some people shorthand it, some people write the numbers all the time. Capital G, the gravitation constant, is 6.67 times 10 to the negative 11. Okay, if you're going to write it out in number form, I'm going to do that here. If you're going to do it in abbreviation form, I'm going to do it down here. We have that abbreviated in our calculator as capital G. I am now going to multiply that by the mass of the Earth. The mass of the Earth is 5.98 times 10 to the 24th. Okay, but I have it saved in my calculator as alpha m. So I can just abbreviate it alpha m as long as you know you're working with the mass of the Earth. I need to divide that by the radius, and I have to remember to square it. That's the number one error people make more often than any others is they forget to square their radius. So on the bottom, I have the 6580000. 658,000, and I need to square that number here as well, 658,000 squared. Okay, I try to write it out like this just so you guys can follow along with me a little easier, but once again, you can abbreviate it instead of writing out the numbers because you have them stored in your calculator. Okay, the easiest way to actually calculate this using your calculator, you hit alpha G times alpha M, hit enter, and then divide it by 658,000 squared. And if you do your math correctly, you will find that the little g comes out to be 9.21 meters per second squared. So getting 210,000 feet off the surface of the earth decreases your gravity by a little bit. Normally it'd be about 9.8, now it's about 9.2. So it would make you feel a little bit lighter. All right, from here, to find the weight in newtons, you already know your weight equation. Weight is mass times gravity. Weight is in newtons. Mass is the m, we have to have it in kilograms, and g, little g is always gravity. It's an acceleration, so its units are meters per second squared. Okay, example 2 is a continuation of example number 1. If you have a mass of 60 kilograms, so we're not talking about you, you have a mass of 60 kilograms, what would be your weight at the height in the previous problem? So in the previous problem, we were 210,000 meters above the surface of the earth. We have already solved for our gravity at that height, so the gravity is 9.21 meters per second squared. If I want to solve for my weight, I just take my mass times the gravity. The mass is 60 kilograms. The gravity was 9.21 meters per second squared. When I multiply those two by each other, 60 times 9.21, I got 553, once I rounded it to a whole number. And it is a kilogram times a meter per second squared turns into a newton. That's what a newton is. It's a mass times an acceleration. Okay, so one new equation, one repeated equation. Okay, our new equation here, to solve for gravity anywhere that you're located, you need that gravitation constant, 6.67 times 10 to the negative 11. You need to know the mass of the object creating the gravity, the Earth, Mars, the Sun, wherever you're located. And you need to know the radius, the distance all the way to the center of the object. Once you know the gravity at your new location, you can multiply it by your mass in kilograms, and it will give you your weight in newtons. All right, as we flip over to the problem piece of it, we are going to do a couple of these together. So we are going to go through question number 1, and then we are going to go through question number 4. Having seen these, then that will help you with the other questions, because I repeated a few just with different numbers. Okay, problem number 1, find the gravity on the surface of the moon. Okay, we know if you go to the moon is much smaller than the Earth, so there is less gravity there, you're going to feel lighter. Okay, so we're going to actually calculate it. See the bottom left side of your equation? I think it's bottom right, sorry. Bottom right side of your equation for the mass and the radius of the moon. It's where it says gravitation constants on the bottom of the back of your equation sheet. Okay, when you do that, anytime we want to solve for gravity, we need to use this equation. G equals capital G times the mass divided by the radius squared. Okay, if you look on the back of that equation sheet, it tells you the mass of the moon is 7.35 times 10 to the 22nd kilograms. And it tells you the radius of the moon is 1.738 times 10 to the 6th. Okay, knowing those two numbers, I always know this, 6.67 times 10 to the negative 11. I now know the mass of the moon and I know the radius. I'm going to solve for the gravity. All right, so little g equals, you can write it as capital G, or I'll just put the numbers in there so I don't confuse people, 6.67 times 10 to the negative 11. I need to multiply that by the mass of the object making the gravity, that is the moon. The mass of the moon, it's on my equation sheet, 7.35 times 10 to the 22nd. I need to divide that by the radius of the moon, and I have to remember to square it. That's the most common mistake that people make. The radius is 1.738 times 10 to the 6th, and I just need to then plug that in. All right, if you type this all into your calculator, the correct answer is 1.62 meters per second squared. Please check that and make sure you can get that to work. I'm going to pull up the calculator real quick, and this is actually, what's it called? It is the Graph and Calc 83. If you don't have a graphing calculator, I highly suggest that you use that in order to just go to self-service and grab it out of there, get it in there, and then you can use that for all of these. Okay, I did already store G in there. So I'm going to hit alpha G, and then I'm going to hit enter, and I already stored 6.67 times 10 to the negative 11. So now I'm going to multiply this. I got to use parentheses by the mass of the moon, 7.35 times 10 to the 22nd. Let's see, delete. I then need to close my parentheses. I got to use the down arrow. For some of the calculators, some you don't have to. You just need to get it back to the regular size, close it, and then when they multiply, I'm going to hit enter. To that number, I need to divide by the radius squared. In parentheses, because you're using scientific notation, use your parentheses, 1.738 times 10 to the 6th. Sorry. Make it bigger by pushing the down arrow. Close the parentheses, and then you just hit the squared button right there. And when you hit enter, it gives you 1.62 with a bunch of decimals. 1.62 is your correct answer. Okay, so hopefully that helps. Fast forward me if you know how to type it in. Otherwise, try it with me a couple of times. All right, so I now know the gravity on the moon. So for part B, what would be the weight in newtons if you're 75 kilograms and you're on the moon? Well, weight is mass times gravity. Your mass, it just told me, is 75 kilograms. I just found the gravity to be 1.62 meters per second squared. When I multiply those together, I get like 121.7. I just rounded it up to about 122. All right, so problem number 1, we had to first solve for gravity, plugging in all those numbers, and then we had to solve for your weight in newtons. Number 2 is going to be really similar, except that you are going to use the numbers for the sun. Once again, they're on your equation sheet. I have the Earth, the Moon, and the Sun because we use them most often on the bottom of the equation sheet. For number 3, you are going to find the gravity where a Sprint satellite is orbiting 650,000 meters above the surface of the Earth. Just to point it out, if we know that capital G is always our 6.67 times 10 to the negative 11. We are above the surface of the Earth, so the mass is going to be the mass of the Earth, 5.98 times 10 to the 24th. And our radius, you have to add the Earth's radius to how far above it you are. We are getting from the center of the Earth to the surface. That's the Earth's radius, the 6.37 times 10 to the 6th. And to that number, we have to add how far out we are, which in this case is 650,000. When you add those together, let's see, what did I get? 702,000. 7, forgot already. All right, so you have to use that number for your radius on the bottom of the equation and not just this or just that. Okay, number 4, we are going to try this equation, same equation as before, but we're going to try solving for a different variable, okay? So, how far away from the center of the earth? Solve for r. We want to know how far away from the center of the earth would I need to go in order for the gravity to be less than it normally is, which is, we're going to try and solve it for 7.65. Okay, so same equation. I know that the gravity, little g, is 7.65. I know that I'm working with the earth, so the mass of the earth, you've got it stored as alpha m. I'm just going to write it on here, 5.98 times 10 to the 24th. Okay, I am solving for r. That is my unknown. I'm going to have to move all my variables around in order to get that. Okay, so switching colors here. Little g, 7.65 equals big G, 6.67 times 10 to the negative 11, or in your calculator, just write alpha G, times the mass of the earth, 5.98 times 10 to the 24th, or alpha M, divided by what we don't know, and it always comes squared in this equation, so we are going to have to square root our final answer. Okay, so first thing that I do, I multiply these two numbers. You can multiply them out like that, or you can go alpha G times alpha M. When you do that, I'm just going to kind of reposition my equation. I have 7.65 equals, these two multiplied by each other, I get 3.98866 times 10 to the 14th. And that is over r squared. From here, you've got to cross multiply and divide. The r squared gets multiplied to the other side. So I got to multiply by r squared to cancel it out. And then to get the r squared alone, the 7.65 has to go under. Alright, so in order to solve this equation, you're cross multiplying and dividing. So if you're not following me, that's all I'm doing. You just have to spread it out and do more work. But you have to take this number right here and you have to divide it by 7.65. Okay, when you do that, you find that r squared equals 5.21, there's a lot of decimals, I'm not writing them all down, times 10 to the 13th. That is not r, that is r squared. So my last step is to square root, and when I do that, I find that r is equal to this number right here. Some calculators will give it to you in scientific notation, most of them will give it to you in the actual number form. So 7220758 meters. Whew, cross multiplying and dividing. Okay, number 5 is a repeat. It's just like number 4. I wanted you to do one with me and then be able to try one, making sure you can move all your variables around and go from there. And number 6. Number 6 is just like number 1, A, and B, except I put it into one problem. Okay, so you are going to try to find your weight in newtons up 322,000 meters above the surface of the earth. That's where the space shuttle usually flies. Okay, so step 1, we're going to have to solve for the gravity at that location using our gravity equation. Once we know our gravity, step 2 will be to solve for the weight in newtons. Okay, you just have to be careful. When you want your weight, you have to use your mass, which is 110. When you want gravity, you can't use your mass. You don't make gravity to keep us, you don't have any space shuttles orbiting around you, only the Earth does. So this mass is the Earth's mass, the 5.98 times 10 to the 24. Okay, I'm available on Remind. I will be teaching this on Tuesday and Thursday, hours 1, 4, 5, 6, and 7. Hop in at any time to ask questions or send me pictures on Remind. I know it's a lot of numbers to put into calculators, but hopefully it'll go smoothly for you. Thank you.